Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today inshallah we will start together to know how we can prepare salts inside the lab. This part is involved for IGCSE students. At first we will know how we can prepare different types of salts, like for example if he asked you to prepare salt of copper sulfate, salt of ferric chloride, salt of ferrous chloride, magnesium chloride, and all of these different types of salts, how we can prepare them inside the lab. Let's start together now to know the methods of preparation. At first, you need to memorize all the equations for the preparation of salts. You can find it in the link down in the description box. If you want to memorize the equation for salts preparation, okay? Now we will start together to know different types of salts. We have two different types of salts according to the salt solubility in water. We have salts like sodium chloride. They are salts can dissolve in water and form solution, clear solution. And we have salts that they are insoluble in water. They form suspension. They form suspension. Suspension are insoluble in water. So at first you must memorize the different types of salts which can form solution and the types of salts which are insoluble in water. At first, soluble salts in water, all of these salts are soluble in water. Sodium, potassium, ammonium, nitrate, and acetate. So, if you have any salt contain cation or anion from these compounds, contain cation like sodium, like potassium, like ammonium, they are soluble in water. If we have compounds contain anions like nitrate and acetates, they are soluble in water. The second compounds, all halides are soluble in water, except silver halides. Silver chloride is white precipitate, silver bromide is creamy precipitate, silver iodide is yellow precipitate. Lead halides are lead chloride, lead bromide, and lead iodide. They are insoluble in water. Most of sulfates are soluble in water, except barium sulfate, lead sulfate, and calcium sulfate. They are insoluble in water. They can form suspension. All carbonates are insoluble in water, except if we have carbonates contain the following cations: sodium, potassium, or ammonium. All of these carbonates are soluble in water and can form solution. So you must memorize the different types of salts. Now we will start to know what's the constituents of our salt. Our salt consists of two main parts. Any salt is like our family. Any salt consists of cation. He is the father. He wants to leave all our baby. He didn't like to carry baby, so he will transfer the electron to the mother. So our salt is like family. We have father will start to travel or transfer the baby to his mommy. So we will have cation, we will have father is cation, and we will have anion. At first, in cations we have different types of cations, like metal, metal oxide, metal hydroxide, metal carbonates, and metal salts. All of these can be used as a source of cations. If we want to prepare soluble salt in water, we can use metal nitrate or metal acetate, because all nitrate compounds and all acetate compounds are soluble in water. So if we want to prepare salt soluble in water, silver nitrate, okay, copper nitrate, okay, potassium nitrate, okay. All of these compounds are soluble in water, and the same in the case of acetate. The other part of our family and the main part in our family is our mommy. Our mommy will carry the baby. She will start to take care of her baby. So our mommy is anions. Anions are non-metals like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, and so. If you want to prepare salt soluble in water, take care we will add anions attached to cations of sodium, potassium, or ammonium, because all the salts of sodium, potassium, and ammonium are soluble in water. Take care of these informations are repeated a lot in the exam. Now we will start in explaining as general the different types of preparing of salts inside the lab. At first we have neutralization reaction. In neutralization reaction we will react acid plus base. Our base is insoluble in water to form soluble salt. Like at first we can react metal like magnesium plus acid to form salt plus water. Take care in this method the most reactive elements we can't use it, like for example sodium, potassium. We can't use these elements because they are very reactive, so their reaction is unsafe. We can't use the lowest reactive elements like copper, silver, platinum. They are very unreactive elements. And if you want to memorize it, return to the last video. The other type of reaction, we will react metal oxide plus acid to form salt plus water. We will add copper oxide. Copper oxide is insoluble in water to, for example, hydrochloric acid. And the last type of reaction, we will react metal carbonate, like for example we will add piece of calcium carbonate to our acid. The reaction will form salt plus water plus carbon dioxide. Carbon dioxide we can detect it by using lime water. Lime water will turn cloudy after the reaction. Number 2, titration reaction. In titration reaction, we will react acid plus alkali. Alkali is soluble in water to form salt plus water. So we will react acid plus alkali soluble in water to form salt soluble in water. In this method, we can use titration between acid and base using an indicator like phenolphthalein. Phenolphthalein color, its color in acidic medium is colorless. Its color in neutral medium is colorless. When we start to finish titration by adding excess of base and making swirling, we will start to convert color from colorless into pink. So we start to transfer from acidic medium to neutral medium step by step. So we can say we have finished our neutralization reaction by the first change in color from colorless into pink color. Last type of reaction, precipitation reaction. We react two soluble salts are reacted together to form salt insoluble salt in water. So in our reaction we will have precipitate like this precipitates exactly. We will have precipitate insoluble in water. Now we will start to memorize the steps of preparation salts inside the lab step by step. At first, neutralization method. It is method A. It is used for preparing salt soluble in water from the reaction between acid and metal, acid or metal oxide, acid or metal carbonate. At first, we will start to explain an experiment used for preparing copper sulfate by using copper oxide, black powder, plus the sulfuric acid, dilute sulfuric acid. At first, we must start to make warming of our reaction. We will start to make heating for our reaction. We will start to add copper oxide by using spatula and stir. Add and stir. Add and stir. We must add and complete in stirring till we have precipitate. By having black precipitate of excess of copper oxide, we can say our reaction is completed, because dilute sulfuric acid is our limiting reagent. We must complete adding till all of dilute sulfuric acid in our reaction is finished. So we must start to add and stir till having precipitate of copper oxide. By having excess of copper oxide precipitated, we will start to cool. After that, we will start to make filtration to remove the excess of copper oxide. So excess of copper oxide will stay on the filter paper as residue, and down we will have filtrate containing copper sulfate solution. Copper sulfate crystals are hydrated crystals, so you must separate it by using crystallization. You are not allowed to use evaporation because we have hydrated crystals. To have the structure of the crystal, we must make crystallization. So we will start to make crystallization till we have saturated solution. How we can be sure we have saturated solution? We will start to add glass rod. On the glass rod, we will have small crystals started to be formed. Or we can use slide and start to add drop of your solution. If you add drop on the slide and you have small crystals, be sure we have saturated solution. We have concentrated saturated solution of copper sulfate. Leave your solution to be cooled for enough time. After cooling, we will start to make filtration. After making filtration on the filter paper, we will have blue crystals of copper sulfate. We will have blue crystals of copper sulfate, and down we will have the excess of solution. We will start to take our crystals of copper sulfate and wash it with distilled water to remove any impurities in your crystals. After removing any impurities in your crystals, start to dry your crystals between dry filter paper. These steps are the most accurate steps for making the neutralization reaction. Each step you must know it. You must know the arrangement of the following steps and how we can do it. Okay? Now we will start to complete in knowing the hydrated crystals. All hydrated crystals must be separated by using crystallization, because in the case of these crystals, as we can see in our table, each molecule contains molecules of water, so we have hydrated crystals. Like for example, copper sulfate CuSO4 5H2O, it is hydrated copper sulfate. Each one molecule of copper sulfate contains 5 molecules of water, so its name is hydrated copper sulfate. We have magnesium sulfate, hydrated magnesium sulfate. Each one molecule of magnesium sulfate contains 7 molecules of water. We have gypsum is calcium sulfate hydrated. Each one molecule contains 2 molecules of water. They are really great crystals. We have green crystals of the ferrous sulfate. Each one molecule contains 7H2O. We have the ferrous sulfate. We have white zinc sulfate crystals, and at last we have pink cobalt chloride. Pink cobalt chloride, they are hydrated crystals. Each one molecule of cobalt chloride contains 6 molecules of water. They are hydrated cobalt chloride. All of these hydrated crystals must be separated after the neutralization reaction by using crystallization reaction. We are not allowed to use evaporation directly because we want to have regular structure of our crystal. Now we will start to complete in titration reaction. In titration reaction, we will react acid and alkali. Alkali are soluble in water to form soluble salt in the water. At first, in our reaction, we will start limited amount of our acid. Our limited amount of acid, we will add it with the accurate measuring pipe. By adding the measuring pipette, for example, we will add 50 centimeter cubic of acid. We will add 1 drop of our indicator. The most accurate and preferred indicator is phenolphthalein. Its color in acidic solution is colorless. And we start to make titration by adding drops of base and swirling. Add drops of base and swirling till we have pink color. The first drop indicating the change in color from colorless to pink, so we have finished our titration. So we have neutral solution. After having the neutral solution, we can do any one of the following steps. The first one, we can remove our solution and repeat the experiment by adding the same value of acid. Don't add indicator, cancel the following step and start to make titration by adding base with the same amount which you added in the last experiment by exactly the same amount of base. For example, if I added in the first experiment 10 centimeter cubic, I will repeat the experiment in the same steps and I will repeat the experiment without indicator by adding 10 centimeter cubic of base. It's okay? We have another way of separating our salt. Take care, our indicator is like impurities. We can't separate our salt with indicator. So we have another choice to take your solution and start to add charcoal. Charcoal, it is type of coal which can be added in crystallization reaction to remove any impurities. By adding charcoal, start to make warming to your reaction and then we will start to make filtration. By making filtration on the filter paper, we will have the charcoal. We will have the excess of charcoal on the filter paper. And down on the filtrate, we will have our solution. On the filtrate, we will have our pure compounds. We will have our pure salt. The salt we can separate it by making crystallization, by making evaporation. We can separate it anyway and we can take pure crystals. We can take pure salt. And we will repeat the steps of crystallization in the last method. The third method for making the salt and preparing salt in our lab is precipitation reaction. In precipitation reaction, we will react two soluble salts to form salt insoluble in water. Our salts which are insoluble in water, we can find their name. They are collected like silver chloride, silver bromide, silver iodide, lead chloride, lead bromide, lead iodide. We have barium sulfate, we have lead sulfate, calcium sulfate, and most of carbonates are soluble in water. In this reaction, we will start to react two salts which are soluble in water like barium chloride. Barium chloride, we will react it with sodium sulfate. They are soluble in water to form barium sulfate plus sodium chloride. In this equation, we can write the ionic equation, half ionic equation, for forming barium sulfate. Barium sulfate is our precipitate. It is the solid format. We will react barium Pa plus 2 will react with sulfate SO4 minus 2 to form barium sulfate. In this reaction, we have sodium chloride reacts as spectator ions. Spectator ions, they are ions just for watching the reaction, not included inside the chemical reaction. They are just for watching. They are forming a salt which is soluble in water. But our main salt is insoluble in water. We can see our experiment in the first picture. We will add silver nitrate soluble in water plus calcium chromate plus sodium chromate. Sodium chromate and silver nitrate will react together to form silver chromate. Silver chromate is the brown precipitate which is insoluble in water. It is formed directly just by adding the two soluble salts together. So we have finished the 3 different steps for preparation of our salt inside the lab. In the next video, inshallah, we will complete in the mole study. Thanks for watching our video. I hope that you understand our video today. Don't forget to memorize all the following equations and all the following information step by step because they are usually involved in IGCSE exam. Thanks for watching. Don't forget to give us like and share and send the video to your friends. And don't forget to make subscribe in our channel to receive a new video. Thanks for watching. See you later. Assalamu alaikum warahmatullahi wabarakatuh.